So, yeah. So today I'll be talking about the effective way of developing an Android application using MVP. And MVP stands for Model View Presenter. So before going into and starting with uh, like MVP and all that, so I'll just walk you through the agenda. So first we'll be talking about what is MVP, what it stands for. Then we'll go through the current scenarios in the Android development. So how do we write the app right now? What are the old school methods of writing the Android app? Then we'll go through and see how MVP rescues us from the complexity of writing the app without MVP. And then we'll go through and have a UML walkthrough of the demo app. And then we'll have a code tour of the demo app that I developed using MVP. So before going into how many of you are like developing the Android app using MVP? So like yeah. So yeah, not many. So yeah, so we'll just dive in. So what is MVP? MVP stands for Model View Presenter. It's an architectural pattern derived from Model View Controller, and it's mostly used to design user interfaces. So MVP has three components: Model, View, and Presenter, and we'll go through each and see what they do and what each component means. So model is an interface representing the data to be displayed. So for example, a model can be a database, a backend point, or any API server. A view displays data. It's a GUI, it's a user interface which displays data and interacts with the user and takes inputs from the user. Then the last component is the presenter. Presenter is basically a middleman sitting between the model and the view. So for example, my view wants some data from the model. So it will ask the presenter to retrieve the data from the model. Model will hand over the data back to the presenter, and presenter will pass it to the view. So you can see it through the diagram that there is a view. There is a bidirectional communication between the view and presenter and the model. So this is what MVP is. We'll go through and see how the Android app are being designed. Yes.
What's the difference between that and MVC? Can you?
Yes. So if you see MVP, in MVP, view interacts with the presenter and presenter interacts with model. View does not directly interact with the model. But if you see MVC, the user can interact with, so the thing is user interacts with the controller. Controller asks model to supply some data or do some background task. Model then passes that data to the view, and then view displays it to the user. So it's like model communicates directly to the view in model view controller. But here it's a pipeline, and so model does not directly communicate to the view. So it's more like you'll have to go through the pipeline. It's not jumping from model directly to the view. So you may have around 5 to 6 different views in your app, and it may create complexity and code spaghetti if different models are directly jumping and sending data to different views. So that's the difference between model view presenter and model view controller. So in the current scenario of Android design and writing apps, the XML layouts represent the views. The activities and fragments are the controllers, and the plain old Java objects are the models. The unfortunate fact about the views with our current scenario is that the XML layouts cannot handle data bindings. They cannot handle user inputs. They cannot handle the animation and business logic. Though we can define few animations in XML, they should be shown up through and processing the activity. So with all this, activity acts as a controller, and all these data binding and user input need to be done in the activity. And activity also contains the business logic. So as the project grows and evolves, the controller, that is the activity or fragment, becomes monolithic and huge, and eventually it may turn into a God object, which is displaying the views and even talking to the models. So thus, with this, the code becomes harder to read. It's not testable, and also it's a nightmare sometimes to even refactor the code. So there is, and we'll also see this in the diagram. So so we are writing an Android app, and and after a few cycles or few sprints, this is how our Android app will look if you are using the MVC pattern. So there are a lot of views. They are communicating with the models, and the model are passing data back to multiple views. So it's kind of a spaghetti. There is no separation of concern in MVC. So there is where the MVP comes to our rescue. So MVP to rescue. We'll also see here like why we should use MVP. What is the benefits of using MVP over MVC? So MVP facilitates speed and product quality. So we usually we are using Scrum or Agile for product development and management. And with Scrums we have sprints and lot of project features and changes coming in every sprint. So with this we also need to have good product quality, and we also need to maintain sprint velocity. So if we are using MVP, the code is more simple, maintainable, decoupled because we have three components each performing their own work, and it's also testable. So the other good advantage is focus on business logic. So if we have so in MVC, the controller takes care of the view bindings, which is which is removed here, and the Android so the Android activity is a view right now, and it takes care of forcing all the view operations into the activity, and so we'll be putting all the business logic into the presenter. Thus we are alienating all the view code into activities, which are the views, and all the business logic into the presenter. The other two advantages that we'll be discussing is separation of concern. So because MVP has all these interconnected components with specific set of actions to perform, they do not bother about the code intricacies of each other. So the view does not need to know what the implementation details of presenters are. And even presenter doesn't need to know if the model is a database or it's an API server. So they are like separated from each other. So thus with this separation we achieve separation of concern. And the most important benefit that I love using MVP was the code is almost test ready. Yes, the code is almost test ready. Because the components are decoupled but interconnected, it's easy to determine the type of testing framework that developers need to use. So for testing presenters and models, we can use JUnit test. And for testing views, which are mostly related to Android framework, we can use JUnit, or even we can use RoboElectric. So we can write very nice readable tests using MVP. So moving forward, I'll give you an overview of the UML diagram of sample of the demo app that I have written. Yeah. So you see three green components at the top. These are the interfaces. Main view is an interface to be implemented by the main activity. Main presenter should be implemented by the main presenter implementation. Also, there is another interface called model change listener. So this listener will be called from the data manager if there are any model changes. So if we see the main view, there are 4 different methods. Uh, one is show progress, the another is cancel progress. So whenever the activity asks for any data to the presenter before fetching the data or before telling the data model to fetch the data, ask views to show the progress spinner and cancel the progress spinner once it gets the data. So there are these 2 methods. Then there is another method called show toast. So if there is any error being returned by the model to the presenter will constantly hit view and tell it, okay, this is the error message you need to show. And then the last method that the view needs to implement is update list. We have a list of, we have a recycler view that we need to update with the data. So the presenter will be implementing 2 methods, on create and on stop. These methods are mostly dependent on the lifecycle activity of the view. So whenever we start the app, the on create method gets called for the view. The presenter is notified that this is the time to get data from the model. So we are attaching our presenter to the activity lifecycle. And there is this data manager, which is the data model for us. And so we'll just go through the app, and I'll also walk you through the sample JUnit test that I've written for main presenter, and you can see how easy it was to write a couple of test cases. So this is the main view. Can you see these methods? Yeah. So as I told you, there are 4 methods: show progress, cancel progress, show toast, and update list. This is the presenter interface. It has 2 methods: on create and on stop. And this is the model change listener. These 2 has 2 methods: on success and on error. So I'll just walk you through the main activity which implements the main view. So this is the main activity which implements the main view. So if you see the on create method of this activity, first we are inflating the activity layout file. We are setting the content, and then we are setting up all the views and components. So we have a recycler view in there, which will be showing us the list of images. Then we are creating a presenter. We can use different dependency injection patterns. Frameworks are out there to create, to create these dependencies. But to make the app, to have these apps simple, I'm just not using any dependency injection. So we'll be creating a presenter, and we are calling the on create method of the presenter. So I'll just take you to the presenter, and here, if you see, the presenter implementation is, is implementing the main presenter, and this is the on-create method of presenter. It's being attached to the activity lifecycle, and it's calling the show progress method of the view, and it's also telling data manager that, okay, get me the data. There is the another method implemented by presenter is on stop. It's telling data manager to please cancel any retrieval of data. And these are the two callbacks implemented by presenter. So whenever data manager gets like fetches any data from either database or API, it will notify our presenter, and it will send back. It will call the onSuccess method with the data model, and our presenter will pass that data to the view, and also it will tell the activity like that. Okay, now we have this data. Please cancel the progress spinner. Uh, on error method does the same, but instead of sending data back, it tells activity that please show this toast message that we don't have any data. So this is the sample presenter implementation. Uh, I'll just walk you the through the test that I've written. Yeah, it's a simple JUnit test. We are not using any RoboElectric and any other framework. So you can see that. So I have a setup method where I'm creating a mock view through the view interface. I'm not even using the activity. Yeah.
Could you make it just a little bit bigger? Sorry.
Oh yes, yeah, thanks.
Oh, thank you.
Yeah. So I'm creating a mock view out of the main view interface. I'm creating a mock data manager. Uh, we are creating we are creating a presenter, but we are even spying the presenter. We are calling a spy method on the presenter, and we are setting the data manager. We are setting the mock data manager for the presenter, and we have three different test cases. One is to see what happens when the onSuccess callback is being called for the presenter. So we also see. So we call the onSuccess with a mock model class, and we verify that the cancel progress method from the view is being called, and it's only called one time, not zero or not multiple times, like 2 or 3 times. So it should be called one time, and we are also verifying like the update list is being called once. So the progress spinner gets cancelled, and the view gets the updated data. I've written the same kind of a test for model change error. It cancels the progress spinner, and it calls the show toast message. So we are verifying both, and I'm also verifying the onCreate method of the presenter to see that the show progress method from the view gets called. So yeah, this is a simple JUnit test, and because the way the presenter was being written and the code was not being consolidated into activity, it was easier for me to directly use JUnit and write the test instead of going more deep and making my code suitable for writing this JUnit test. So I'll also show you this sample app, what it does. So okay. So this is the sample app that I'm showing that I wrote the MVP demo. So this is the spinner. It gets called from the presenter, and then the activity gets updated with the list of data. Unfortunately, I'm yes. So now the activity gets destroyed when we rotate the handset, and the onCreate method gets called again. So you see the spinner again. I'm not persisting the data because I wanted to write a simple app. But you can make your presenter, like persist across the configuration change. So it depends how you want to save the presenter their info. So this is the sample app. Uh, just to summarize, mm, I'll just summarize what we went through. So the first point that I think is very much important is to separate the business logic by moving it into presenter. We should always do that if you want to implement the MVP pattern. And always test your presenter. I suggest you to test your presenter thoroughly and make sure it is independent of any view related code. We don't want any Android framework related code into the presenter. Also, try to attach or detach the presenter or keep the presenter persistent on configuration changes. It's more subjective and related on the type of app you are writing. The last is activities and fragments should implement the view interface. So those are the views and those should be implementing the interface but not any other Java classes. So yeah, so this is it from me. I would have gone more into list and recycler views but that's out of the scope. And I don't want to stage this talk more. So yeah, that's. Any questions?
Yeah, I have a question. So when you're determining, okay, functionality for the app and things like that, do you have different staff working on the different parts? Or do you have one programmer working on the M to the MVP?
It depends. We can collaborate with different programmers if to work on model and view or presenter. So we can have different developer working on model because it is all implemented to the interface. I don't think they like it should be very easy because we get the API, the interface, the blueprint, and it's really easy to communicate and work on different models of these like MVP.
Right.
Yeah.
Okay. And then a follow-up question: do you think that this kind of helps you ensure that cross-device functionality is going to be closer to each other, as opposed to if by separating out, you can kind of ensure that the core logic, the business logic, is going to be for sure the same, because if you're comparing apples to apples, as opposed to having to sift through some of the device-specific or OS-specific code with it.
Uh, yeah. So if it's really dependent on the framework, I think we should put that into the view. Because if it's not related to framework, it should go into the presenter. So like we should decide what we want in presenter, but usually we don't put Android related, Android framework related code into the presenter.
A question about that. You know the data binding API that Google came out with. Is that an example of the MVP, or how does that fit into this whole MVP pattern?
Yeah. So I think that data binding API that is part of a view in the MVP because I was also using butter knife and yeah. So it's related to view.
Okay, so it's just one component of the whole pattern.
Yeah. Yes. Yeah, because you bind this data in your activity into the XML layout. So yeah.
And also the espresso, how does that play into what can be tested? Is it just the views that can be tested?
Because Espresso is a UI testing framework, we can test like there is no problem testing the views and presenters. Yeah.
Okay. Espresso doesn't